Science Sav. Today we're doing the super famous elephant toothpaste experiment, but we're going to explain how it works, why it works, and hopefully give you some really fun things to do at home. So to make elephant toothpaste, what we need is some dish soap. The more bubbly, the better. We also need some hydrogen peroxide. This is the stuff that you put on wounds, cuts to sanitize them. And chemically, this is spelled out H2O2. And then we're also going to need some dry yeast like you would use for baking. We also need some containers. These can be bottles, like water bottles, or we have fun little cylinders here to contain our elephant toothpaste and help it spread out. And then last but not least, we need some food coloring to give it some fun color. So we have all of our ingredients assembled. Now it's also a good idea to bring along a sheet pan to collect some overflow explosion of your elephant toothpaste. But besides that, we got our soap, we got our food colorings, we have our yeast, and then we have hydrogen peroxide. Now you have a few options with the hydrogen peroxide. You can splurge and get the 12% or 30%, which are more industrial grade, higher concentrations of the hydrogen peroxide. Or the type that you would get in the drugstore is 3% to 6%. So there you have less of the reactant, hydrogen peroxide, and so your explosion is going to be not quite as dramatic, but that's okay. It'll still be super cool. So guys, a fun thing that you can play around with this experiment is trying different shapes and sizes of container, because that will make the elephant toothpaste explode out in different ways. And so today we have a tall cylinder, a medium beaker, a smaller cylinder, and a small beaker. And so we're going to see what the difference is between these four. We also need some warm water to activate the yeast. And so what we're going to do before we do anything else is go ahead and open your little yeast packet, and you're going to pour it into a little cup of warm water. Just like so. So we have our warm water in here, which is activating the yeast. And this just means that while the yeast was dried out, we're basically submerging it in water to rehydrate it. And this reactivates all of the enzymes that are in the yeast. Now there's an enzyme in the yeast called catalase, and that is what is going to be the catalyst for our reaction. So the yeast plays a super important role in making the reaction go super fast and making it really dramatic and cool. So we also have our food colorings over here. I chose some pink, some green, blue, and turquoise. And so this will be a fun mix of colors for us to color our elephant toothpaste. And then I also have my little thing of dish soap and our hydrogen peroxide. So now we're ready to start making our elephant toothpaste. So the first thing we're going to do is add some soap to the bottoms of our beakers. So now we're going to add the hydrogen peroxide, and they're going to mix with the soap. And be careful when pouring. Try not to get it on your skin if it's the higher percent. Wear gloves if you're worried. So now it's time to add some color to your elephant toothpaste. If you want just a single color, you take your food coloring, you drip it in and swirl it. If you want a few colors, like a swirl, I'm actually going to show you how you can drip it down the sides to give it multicolors like you would envision the classic toothpaste. And so we're going to do a mix of both here. We're going to have these two be one color and these two be multicolored. Okay, so now we have all of our reactants ready to go. We have the soap, we have the hydrogen peroxide, we have the food coloring, and we have our catalyst, the yeast. And so now it's time to combine it all together. So as you can see, the different shaped cylinders give you a different shape of elephant toothpaste coming out the top. My favorite so far is this medium-sized beaker, which is sprouting out like you would envision toothpaste to. While the taller, skinnier ones seem to have less of a force coming out of the top that provides this nice shape. Man, I'm really obsessed with all of these colors, but this one is my favorite. The stripes that you get from the dripping down the sides, super cool. Highly recommend. So what happened here? Well, the hydrogen peroxide, which is our key reactant, broke down into oxygen and water. And the soap was there just to capture the oxygen in tiny bubbles, which then exploded out of our containers because the reaction was happening so quickly because we added the yeast. The yeast was the catalyst that made this reaction happen in the dramatic, fun way it did. Without the yeast, hydrogen peroxide will still break down into oxygen and water, just not as quickly. Now parents, you might be wondering, is this safe to touch? Well, it is, because this is all just oxygen captured in those soap bubbles. What's also really fun and a really interesting part of chemical reactions is these bubbles are warm because the reaction is so energetically favorable that it releases energy in the form of heat. This is called an exothermic reaction. Comment below if you think adding more soap, hydrogen peroxide, or yeast is the key to making a more dramatic reaction. In next week's video, we're going to experiment with adding more or less of these different components to get the tallest elephant toothpaste funnel we can. Let's see how many of you can get the right answer. So this super fun, super simple experiment can help demonstrate some really key chemical concepts. The first of which is the concept of turning reactants into products. Our reactants in this experiment was primarily hydrogen peroxide. And we turned the hydrogen peroxide into water and oxygen. So the other concept we're learning here is the idea of having a catalyst. And so the catalyst here was the enzyme catalase that was found in our yeast. And this was what made the reaction happen super fast. And so the last concept we addressed here was the idea of chemical energy. And so in this reaction, more energy was released from the bonds than what was turned into water and oxygen, which made it exothermic. And we know this was true because when we touch the elephant toothpaste and when you touch the beakers after the reaction is complete, you can feel the heat that was released from the chemical bonds. Now you know how to make the basic elephant toothpaste. Thanks so much for watching. Make sure you like and subscribe if you want to get more of this content.